Hi guys, welcome to the video. Today we'll be talking about trigonometry, specifically solving trigonometric equations. And this will be the first part of a series of videos. So first of all, what is a trigonometric equation? Well, it's simply an equation that involves one or more trigonometric functions. So for example, here is sine of x equals 1. Sine is a trigonometric function, and since we have an equality between these two, then it's a trigonometric equation. Likewise, we can have more trig functions. Like here we have a sine and a cosine of x each, as well as a tangent, and these are all equal, so it's a trigonometric equation. And generally when we're messing with these, we're trying to answer the question, what values of x satisfy the equation? Certainly we could just try plugging in a value of x and see if it's equal, but we need a little more systematic way to go about this. So let's look at an example. Let's try to find all the solutions to sine of x equals -1/2. So now how can we try to start tackling this? Well, we have a few methods, and one of them is just memorization of the values of trig functions. So if we know every single value of sine, then we should be able to figure out every single x value that gives us the output -1/2. Well, remember that there's an infinite number of inputs that we can plug in here, so this is very unreasonable. Generally, you try to memorize just the first quadrant of the unit circle, so from, let's say, 0 to pi/2, and from there you can get all the rest of the normal points on the unit circle, and if there's other things, we typically have to use a calculator or something along those lines. So, what we're going to try to do is instead use the unit circle. And the reason why we can use this, why this is useful, is because all the points on the unit circle are of the form cosine of x, comma, sine of x, where x is the angle above the x-axis. So if we can look at the unit circle and try to figure out what y-coordinate or x-coordinate we need, we can figure out what the angle is from that. So for this example, we need to find all solutions. We said that there was infinitely many, so what we can do is that since sine is 2 pi periodic, we only have to look at 0 to 2 pi. So what I mean by 2 pi periodic is that every 2 pi we just repeat the same process. So if you look at a typical sine graph, it looks wavy and it just keeps repeating. So what we can do is find where it stops doing the same thing, and then we just look over there and we can extend further. For this example, since we know that cosine is the x-coordinate and sine is the y-coordinate, we can just use this value right here. So since we're looking for solutions of sine of x equals -1/2, well, sine is the y-coordinate on the unit circle. So we're looking for a y-coordinate being -1/2. So if we just kind of use our hands to do a reasonable approximation, well, y-coordinate is the vertical, so we're going to -1/2. So here's 1, here's 1/2. So we're right about here. And if you remember from your unit circle, here we have exactly -1/2 as one of our answers, and -1/2 is our answer. Again, we're looking for the y-coordinate, so we're looking for the second coordinate. We don't care about these other ones. And what we can do is if we don't know all of these values, we can kind of flip them around, and there's some type of symmetry going on. So we're looking for, essentially, this angle right here is going to be pi plus pi/6, because this is 1/2. And likewise, this point here is going to be 2 pi minus pi/6. So therefore, for just in our, from 0 to 2 pi, we have two solutions, 7 pi/6 and 11 pi/6. So let's go to the board to find all our solutions. So what we just found was that some solutions to sine of x equals -1/2 was that when x is between 0 and 2 pi, the only solutions are 7 pi/6 and 11 pi/6. But our question was to find all the solutions. So what are we going to do? Well, since this is 2 pi periodic, all we have to do is add or subtract as many 2 pi's as we want to any of these solutions. So for example, if I add 1 2 pi to this guy, this is also a solution. If I subtract 2 pi, that's another solution. If I subtract another 2 pi, this is another solution. So the way we typically write this is that we say we have x equals one solution. And what we can do is we can add or subtract, or let's just say add, 2 pi, but we can add as many of these as we want, so we just write a little n times it. So for example, if n was equal to 2, then we're adding 2 pi's, so that's still a solution, as well as our other solution with the same type of pattern. So we're going to add 2 pi n, because we can go around the unit circle as many times in either direction, as long as we go all the way around 2 pi. And where n is an integer. So just a quick check. N, if n's an integer, n can be 0. So if you plug in n equals 0, we get our original solutions that we know work. And if you pick any positive number, that means we're wrapping around the unit circle that many times. So that's still a solution. We land on the same spot in the unit circle, and likewise it works for this other one. So therefore our solutions are exactly 7 pi over 6 plus 2 pi n, and 11 pi over 6 plus 2 pi n, where n is an integer.